Hello everybody. Today we're going to be looking at 3.3 common factors of a polynomial. So what we're going to be doing today is we're first going to look at some algae tiles. You've definitely used them in the past, and if you haven't, we'll go over them quickly to what they mean today. So in the first example, what we're going to do is we're going to look at factoring each binomial. What we're going to do is we're going to use the algae tiles. So I have a program here that I'm going to share with you. It's a neat little program that you can use for the algae tiles, and it's going to help you build on some what's called factoring. Okay, so what we're going to do first is we'll bring our program up. And our program uses x squared, and then the constant. So if you have n, that can be equivalent to x, right? So you're more looking for the exponents. So I'll show you what that looks like in a minute. So in the first example, it tells us 6n plus 9. So we're going to use x as n. It's equivalent. So we're going to need 6 of these. 1, 2, 3, 4, 6, and then we're going to need 9 ones. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what we want to do is we want to create a rectangle. You can swap, like if you want to change the rectangles, you can turn them like that if you want. Okay, it's up to you though. But make sure they're all going in the same way. So I'm going to make sure they're all the same, right? So we put these together. Let's try to make a rectangle with these ones. There we go. So there's not a rectangle. Not we can do it. So we got to be a little creative, and we got to see, okay, well, what if we bring this up here like that, and then we take this down like that. Perfect. We've made a rectangle. So what this allows us to do is it allows us to essentially factor. So the dimensions are going to be your two factors. So let's grab a picture of this. So, remember what your dimensions are going to be is, if you do recall from last year, remember, for the x tile, the longer side is x and the smaller side is 1. So we have 3 ones here. So this side here is going to be 3, because we have 3 ones. And then this side here, there's 2 x's, so it's going to be 2x. And then there's 3 ones plus 3. And there is your dimensions of your rectangle. And the rectangular dimensions are actually going to be the factors. So we can now say that 6x, I'll bring this down a bit, right? So we can say this is equal to 3 bracket 2x plus 3. Factors. Of course, our diagram there that we have. Factors beside it. Pretty straightforward. Let's look at the second example. This one we have an x squared term. So we have an x squared term. That is going to be one of your bigger squares. So we'll go up to our sheet and our algae tiles for that. So this time we need 6 C's, but that'll be just 6 X's. So we need 1, 2, 3, 4, 5, 6. And I'm going to turn them the other way just to show you it doesn't matter which way you put them. And then we need 4c squared, so the same as 4x squared. Alright. Okay. And then we can add these in like this. Again, our goal is to create a rectangle, right? That's our goal here. And there we are. Okay, so there's our rectangle. So we'll take a picture of that. There we are. There's our rectangle that we've just created using our program, which I will link that to you. Okay, so remember this side here, remember this side, this tile is x squared because it's x times x, so essentially there's two x's there, plus 3 again. So again, that's just a coincidence with the last question being the same. 2x plus 3 again. And up top here we have x and x, so we actually have 2x. The whole thing. And there's your dimensions, so this factors 2b equals 2x, or 2c, sorry, I'm using c, I'll fix that, 2c factoring out, and then bracket 3 plus 2c. And we're going to talk about the factoring and what this means a little later on. I use n here, x by mistake, but it's just n. It can represent whatever the variable is. Alright, and this one here was obviously c. I'll leave x in the diagram, and then obviously the n when you do the factoring. But there you are. So we'll do a second method, and second method's called using the greatest common factor. So the first one, I'm going to list the factors of 6n and the factors of 9. So 6n has the factors 1, 2, 3, 6, and n. So those are your factors of 6n. And then I'm going to do the factors of 9. Let's factor 9 here. Factors of 9 are 1. Oh, we don't need that. They're going to be 1, 3 times 3, and then 9. So the GCF is obviously, you can see the GCF is 3 here. So then you pull the factors of 3 out. So that would be one side, and then what you're left over with is the second factor. So it's, what do I multiply 3 by to get 6n? It's obviously 2n. What do I multiply 9 by, or 3 by to get 9? And it's 3. So that's left over. So that's just another way. And again, we can do that with the B example as well. So for the first one, 6c is 1, 2, 3, 6, and c. Alright, and then we got 4c squared. 4c squared. And then those factors are 1, 2, 4, c, and c. Because there's 2 c's. So you list the c's twice. And the GCF, you take the number, hold that, and then you also take if there's any common letters as well. So the GCF in the first one here was obviously equal to 3, but the GCF here is equal to 2C. You got to take both, right? Okay, so just be mindful of that. And that's where this 2C comes from, when you factor out what's left over. When I multiply 2C by to get 6C, what's left is just 3. When I multiply 2C by to get 4C squared, it's like 2C, because 2 times 2 is 4, and C times C is C squared. So that's another way. Okay, so it's basically we're using that distributive property backwards, essentially, than what you're used to. There's a check your understanding question that goes along with this. You can work on that. Instead of rushing, in the next video, what we'll do is we'll look at factoring a trinomial and how that works. Okay, so till the next video, we'll see you again soon. Thank you.